Hello everyone, welcome to example problems on set. This is based on week 1 lecture 1 delivered by Snigdha sir of the course CSE230 Discrete Mathematics. Here we will solve some problems based on the theories explained by Snigdha sir. In the problem 1 we have two sets A and B, both of them are finite sets. The number of elements in set A is 24, the number of elements in set B is 32. And the number of elements in set A union B is 40. We have to find the number of elements in set A intersection B. Can you do it? I would urge you to do this problem by your own. I'll give one hint though, you have to use the inclusion-exclusion principle. Okay, I hope you have done it. Let's see whether your answer is right or wrong. Right. See, the number of elements in set A union B is said to be equal with the number of elements in set A plus the number of elements in set B minus the number of elements in set A intersection B. From there, we can find the number of elements in set A intersection B, that is 16. Let's go on to a real life problem. Say for example, BRAC University entered the inter-university cricket tournament. Our opponent is Dhaka University. They have sent us a list that consists of 6 batsmen, 6 bowlers and 1 all-rounder. So in layman's eye, it may seem that Dhaka University cricket team consists of 13 players. But what is the actual number of players that the Dhaka University team has? Can you relate this problem to number 1? Is there any similarity? I would give you one hint though. The all-rounder is both batsmen and as bowlers. So pause the video now and do the solution by your own. Okay, I hope you have done it. Let's see whether you were right or wrong. Fine. We can say that batsman is a set and the number of elements in that set is 6. We can also say bowlers is a set, so number of elements in that set is 6. As I've said before, all-rounder means batsman and bowler at the same time. That means all-rounder set can be described as batsman and bowler or batsman intersection bowler. The number of elements in that set is 1. We can say the total number of players can be denoted as set batsmen in union bowlers. So we have to find the number of elements in that set. So number of elements in the set total or the number of elements in set batsman union bowler is equal to number of elements in set batsman plus the number of elements in set bowlers minus the number of elements in set batsman intersection bowlers or the set all-rounder. So in that way we can find the total number of players in Dhaka University is 11. So that should be a fair game. Now we have to extend the union rule. I would like you to have a notice on this figure. See, the shaded area means A intersection B, right? That divides the picture here into 3 parts. The white portion of A, white portion of set B and the shaded portion of A intersection B. So set A is divided into 2 parts, white portion and the shaded portion. Set B is also divided into 2 parts, shaded portion and the white portion. The white portion of set A means only set A and not B. The white portion of set B means only set B and not A. And the shaded means they belong to both A and B. So we can write set A as A bar B, that is A only area plus A intersection B. We can write B as B only area plus A intersection B. As we know from inclusion-exclusion problem, A plus B minus A intersection B. So set A can be denoted as A bar B, that is A only area plus A intersection B. B can be denoted as B only area plus A intersection B minus A intersection B. So we know A union B can be written as A bar B plus B bar A plus A intersection B. That is A only area plus B only area plus A intersection B. Let's solve some problems with this extended union rule. See, say for example, Real Madrid have players only from German nationality and from Spanish nationality. However, there are some players who have both their nationality. So they have origin from both German and Spain. So it is given that the total number of players in Real Madrid is 30. The number of Spanish origin players is 14. The number of German origin players and Spanish origin players is 5. What is the German only origin players? Alright. Can you solve this problem on your own? I would like you to pause the video now and do it by yourself. Okay. It is given that Spanish origin players only is 14. So that is only Spain and not Germany. That is why we have written the set as Spanish origin players minus German origin players. The total players, as we have said, they are only from Spain and Germany. So Spanish origin players union German origin players means the total number of players, that is 30. As I have said that there are some players that they share both the nationality. So they are from Spain and they are from Germany as well. The number of the elements in that set is 5. We have to find the German only players. That is the players who have the origin or nationality from only German and not Spain. We can use the extended rule of union here, and using that formula we can say that the German only player is 11. So if I want German origin players, see, in the previous problem I wanted German origin only players or German origin only players, that is they are from Germany and not Spain. But here I did not say that. I said I want the German origin players. That is, I will count the German only players plus the players there from German and Spain both. Do you see the difference between these two problems? I hope you do. And I would like you to pause the video now and do it on your own. See, we have to find number of elements in set G, that is German origin players. For that, we have to count the number of German only origin players plus the number of German and Spanish origin together. So as the previous problem we have solved, the German only players is 11. We have to add the intersections portion of the set, that is Spanish and German origin players, that is 5. So the solution to this problem is 16. Let's move on to a different problem. The representation of a set can be done in 3 ways: statement, roster, and set builders format. If a set is denoted by A and the elements of the set is 1, 1/2, 1/3, 1/4, and so on, can you write it in a set builders form? Okay, I hope you have done it. So let's see whether you are right or wrong. But before I move on to the next slide, I would suggest that you need to find the trend here. 1 can be written as 1 divided by 1, and that is, and now we have elements as 1 divided by 1, 1 divided by 2, 1 divided by 3, 1 divided by 4. So the denominators increase in each element. In the set builders form, we can say that the set A has element x. X is an element that can be written as 1 by smaller n, where smaller n belongs to capital N, and capital N means the set of all natural numbers. See, 1, 6 both are enclosed with closed intervals. That is, we would count 1 and 6 both. So here I will find that 1 up to 6 both of them are included. That is why 1 and 6 I have filled with it red marks. That means 1 and 6 are included, and anything in between them are of course included. See, this is open set interval. That means we will count any numbers that is in between -5 and 3. However, we will not count -5 and 3. That is why I have not filled the -5 point or the 3 point with red marks. It is not filled with red marks. That means I am not counting -5 point and 3 points, the point 3, but anything in between will be included. That is why it is open-ended set intervals. So it can be open close set intervals at the same time. See, it can be we will count 6, but we will not count 2. So we will retain it and set builders form as x is greater than 2. However, x is less than or equal to 6. So I will fill the point 6, but I will not fill the point in set in point 2. I hope you understand this. Okay, so let's find the intersection. -7, -2, none of the endpoints are included. Intersection -5, 5, both of them are included. So we have to find the common area in between these two sets. See, if we put it in the time series, you see -2 up to -7, none of the endpoints are included. And here -5 up to +5, both of the endpoints are included. However, what is the common ground? Anything that is less than -2 and anything that is greater than or equal to -5. So that is why -5 point here is included in the intersection set. However, -2 is not, because -2 is not included in this first set. That is all from my side of this week's problem set, or this lecture's problem set. I hope I will see you again. I'll ask you to do the assignments by yourself. I hope I'll see you next classes. Thank you guys.